Myself, Sanmusundaram, Professor, Sri Ramakrishna Engineering College. This video is about node and mesh analysis. I have used contents of Dr. Firas Sobidet, Philadelphia University. In this presentation, I have discussed about nodal and mesh analysis. Nodal analysis. The steps to analyze AC circuits by node voltage method. Node analysis is also called as node voltage method. So first step is we have to identify the principal nodes, and we have to choose one node as the reference node, and for all other nodes we have to assign some voltages like V1, V2 or VA, VB, etc. So V1 indicates voltage at node 1, V2 indicates voltage at node 2. Otherwise we can name like this also. If the node is named as A, then VA indicates voltage at node A, VB indicates voltage at node B. Then we have to assume current directions at each node and apply KVL to all the principal nodes except reference node, and we have to write the KVL equations in terms of node voltages. Number of equations will be equal to number of principal nodes minus 1. Then after getting equations, we have to solve the equations to find the node voltages. From the node voltages, we can find current in the elements and power. If necessary, we can write the phasor voltages and currents in time domain. Since KVL and KCL is valid for phasors, so AC circuits can be analyzed by nodal analysis and mesh analysis. So we use mesh and nodal analysis to find current and voltages in the circuit. Now consider this example. Find the time domain voltage V1 of t and V2 of t in the circuit shown in figure. So you are asked to get equations for V1 of t and V2 of t in time domain. So now this is the given circuit. So here we have resistance, capacitance, resistance, inductance, resistance, and here we have two current sources. This is one at an angle 0 degree ampere, and this is 0.5 at an angle minus 90 degree ampere. So now you have to identify the principal nodes. This is one principal node. So to this principal node, this current source, this resistance, this capacitance, and this capacitance and this inductance, they are all connected. And coming to this node, this resistance, this inductance, this current source, and this capacitance and this inductance, they are all connected to V2. Then this is another principal node. We have considered this as a reference node. So all the elements, this current source, this resistance, this capacitance, inductance, resistance, this current source, they're all connected to this principal node. Node at which three or more branches connected to it is called principal node. So here there are three principal nodes. One is made as reference node, and one node is assigned as V1 and another node is assigned as V2. So now we have to apply Kirchhoff's current law at this node as well as this node. Then we have to write the equations. So we have to write two equations, one for this node and another for this node. So number of equations will be number of principal nodes minus 1. So number of principal nodes is 1, 2 and 3. 3 minus 1 is 2. So now assume that all the currents are outgoing. So this current in this branch is coming out from this node, and current in this branch is coming out from this node, and current branches are also flowing like this outwards from this node. These are all same node. Then this current, already the direction is given, it is just flowing towards the node. So therefore, if you're going to apply Kirchhoff's current law, then we can write that sum of the incoming currents equal to sum of the outgoing currents, or sum of algebraic sum of the currents equal to 0. So in this case, so the current in this branch is outgoing, in this also it's outgoing, and the current in these two branches also outgoing, and whereas this is incoming. Therefore these are all outgoing currents, so 1 2 3 and 4, and you can equate this current to 1 at an angle 0 degree. So therefore we can write this equation like this in terms of node voltages. Current through this is V1 minus 0 divided by 5, that is V1 divided by 5, and in this it is V1 minus 0 divided by minus J10, just you can write it as V1 by minus J2. Then current through this minus J5 ohms, V1 minus V2 divided by minus J5. So that is this term. Coming to this term, this inductance, current in this is V1 minus V2 divided by J10. So right here. So now equate this current to incoming current. Incoming current is 1 at an angle 0. So this 1 at an angle 0 in rectangular form can be written as 1 plus J0. So now you simplify this equation and separate V1 terms and V2 terms. So you will get 0.2 plus J 0.2 V1 minus J 0.1 V2 equal to 1. Similarly, apply KCL at this node. So assume that the currents are outgoing from this node. So in this branch the current is flowing away from this node, and in this branch also current is flowing away from the node. So these two are outgoing currents. Similarly, currents in these two branches are also, you assume that they are flowing outwards from the node V2. So the current here it's flowing like this, in this branch also it's flowing like this, and whereas this current is already, the direction is given. Therefore we can write equation like this at node 2. Now we will write the equations for this node. So for this branch it is V2 minus V1 divided by minus J5. For this branch it is V2 minus V1 by J10. Then for this branch it is V2 minus 0 divided by J5. Then for this it is V2 minus 0 divided by J10. So these are all outgoing currents, and this is also outgoing current. So therefore when you are writing in the right hand side, you have to write minus of 0.5 at an angle minus degree. If you are writing in the left hand side, just you have to add with the currents. So here it is written as minus of 0.5 at an angle minus 90. So this, if you convert this into rectangular form, you will get J 0.5. Now you again simplify this equation. So rearrange and separate the terms V1 and V2. Then from the above equations, so this is one equation, this is another equations, solve these two equations either by Cramer's rule or by subtraction method. So you will get V1 as 1 minus J2 volts and V2 as minus 2 plus J4. So now you convert this to polar form, you will get 2.24 at an angle minus 63.4 and V2 as 4.47 at an angle 116.6 degrees. So if you want to write these expressions in time domain, it is very simple. V1 of t will be equal to, so you write this amplitude as it is 2.24, then assuming that it is a sine wave, so 2.24 cos of, then omega t. So whatever the angle you write here, if you are getting minus 63.4, you write this angle here. So this implies that the magnitude of this voltage is 2.24, and it is making an angle of minus 63.4 degree with respect to the reference vector, that is horizontal vector. That is, this voltage, the minus sign indicates this vector is lagging behind the reference vector by 63.4 degrees. So with respect to reference line, you can draw a phasor for V1 making an angle of 63.4 degrees in the clockwise direction. So this one V2 of t is 4.47 cos of omega t plus this angle 116.6 degrees. So that is, this one V1 is leading this reference vector by 116.6 degrees. Then coming to example 2, compute the voltage V1 and V2 in the circuit shown in figure. So here, so V1 is this node voltage and V2 is the node voltage here, and this is the reference node. In sometimes the node voltage will not be given in the problem. Sometimes you have to assign the node voltages. So in this case, there are three principal nodes, 1, 2 and 3. This is made as reference node. For this node it is assigned as V1. So voltage at node 1, and this is voltage at node 2. You try to remember here that a voltage source is connected between two principal nodes. If a case of this type arises, then we have to form a super node involving these two nodes. Why we are involving these two nodes? Because the source is connected between these two nodes. Therefore, if you want to create a super node, we have to remove these two branches, and these two nodes should be combined and called as a super node. So now let us see how to write the equations. So now we are going to form a super node. Remove these two elements, right? Whatever the element that is connected across this source, that has to be removed. So 4 also has to be removed. So now only the remaining branches are 1, 2, 3 and 4. Now you assign current direction for these branches. So they are shown here. This is flowing like this, that is towards right, and this is flowing downwards, this is flowing downwards, and this is right. So arbitrarily we have to assume the current directions. So now considering this as a super node, now you write the KCL equation. So that is sum of the incoming currents equal to sum of the outgoing currents. So treat this as a one node and equate incoming currents equal to outgoing currents. So therefore, the incoming current is only this current, and the outgoing currents are this one and this one and this one. So I can write, so incoming current is 3. 3 is equal to the current in this, it is V1 divided by J3, V1 minus J3, and in this it is V2 divided by J6, in this it is V2 divided by 12. So this is the equation. So now again simplify this, separate the terms. So V1 and V2 terms. Now you got one equation. Next, you can also write an equation like this. You see here, since positive term is connected to V1, so V1 minus V2 will be 10 and at an angle 45 degree. So we can write this equation. So now you substitute this V1 in this equation. So if you are going to substitute this V1 in this equation, you can find V2. V2 will be 31.41 at an angle minus 87.18 degree. So if you know V2, then you can substitute this V2 in this equation and find out V1. V1 will be 25.78 at an angle minus 70.48 degrees. So this is how you should solve this problem. Coming to the mesh analysis. Mesh analysis, the steps to analyze AC circuits by mesh current method. You have to identify the meshes, then assign currents to each mesh like I1, I2. So I1 indicates current in mesh 1, I2 indicates current in mesh 2, or can give names as IA, IB, current in mesh A, current in mesh B. Then apply KVL to all the meshes and write the KVL equations in terms of mesh currents. Then the number of equations should be equal to number of meshes. If there are 3 meshes, write 3 equations. Solve the equations to find out mesh currents. So solve them, and then from these currents you can find out the voltage across the elements. If necessary, you can write the phasor voltages or current in time domain. Now consider this example. Determine the current I0 in the circuit shown in the figure using mesh analysis. So now this is the circuit. Here there is a current source phi at an angle 0 degree ampere, and inductor, resistance, two capacitors and resistance, and voltage source. So here there are three meshes. This is one mesh and this is another mesh. This is another mesh. So now you assume currents. I have assumed I1 is the current. Assume the direction as clockwise direction. So you can assign clockwise or anti-clockwise directions. Normally you assume clockwise directions. And I2 is this current, that is in this is second mesh, and third mesh is this one, I3. So now we will write the equations for each mesh. Apply KVL and write the equations. Here this element minus J2 is common between mesh 1 and mesh 2. But if you see the currents, I1 is flowing from like this in the clockwise direction, that is from top to bottom, and whereas this I2, it is flowing from bottom to top. So the current directions are opposite. And coming here, this element J10, it is common between first mesh and third mesh. And here if you see the current directions, I1 is flowing from left to right, I3 is flowing from right to left. So again the current direction is opposite. Coming to this element minus J2, it is common between mesh 2 and mesh 3. Again if you see the current direction, I3 is flowing from top to bottom, I2 is flowing from bottom to top. The current directions are opposite. Okay, now let us write the equations. So you know how to directly write the equation in matrix form. For example, if you want to write this element, so this element is going to be the coefficient of I1. So you have to sum up all the resistance or reactances in the first mesh, that is 8 plus J10 minus J2. So this will become 8 plus J10 minus J2. So this will become 8 plus J8 into I1. The next, coming to the I2, that is this one, this is the element common between first mesh and second mesh. So which is the element common between first mesh and second mesh? This element. So here minus J2 ohms. So now while writing here, if the current directions are opposite, this element is common between first mesh and second mesh. So if the current directions are opposite, you have to write a minus sign, minus of this reactance, minus J2 into I2. Then coming to the I3, you see which is the element common between first mesh and third mesh, that is J10. So now you have to write here J10 into I3, but before that you have to write the sign. Since these two currents are in opposite direction, you have to write here minus. Similarly for mesh 2, for I2 you have to add all the resistance and reactance in this, that is 4 minus J2 minus J2. So you will get 4 minus J4. So this is sum of all the resistances, reactances in the second mesh. Coming to I1, so here this element is common between second mesh and first mesh, so it is minus J2. So minus J2 into I1, you write, and here this minus sign is because these two currents are in opposite direction. So for minus of minus J2. Then coming to the element which is common between second mesh and third mesh, it is minus J2. So therefore you have to write here as minus of minus J2 into I3. So this minus is because the two currents are I2 and I3 are in opposite direction. Then here we have a voltage source in this mesh, and this mesh current is flowing into the positive terminal. So you have to write plus 2 at an angle 90 degree. So this equated to 0. Now coming to this mesh, the current is I3 and already a current source is present in one of the branch. So this current direction and this directions are same. Therefore, I3 will be equal to phi at an angle 0 degree. So I3 is phi at an angle 0 degree. So simply we can call it as phi. So now you substitute this I3 equal to phi in these two equations. Now the two equations becomes like this. The first one becomes a plus j8 into I1 plus j2 I2 equal to j50. The second one is j2 I1 plus 4 minus j4 into I2 equal to minus j20 minus j10. So put it in the matrix form. Now since you are asked to find I0, if you find I2, that is enough. So if you want to find I2, you have to find del 2 and del. So find del and del 2. So del is determinant of this matrix, and del 2 is, that is, you have to replace these two elements by these two elements. So now you find out the determinant. This is del 2. So I2 is del 2 by del. So now you will get this value is 6.12 at an angle minus 35.22 degrees. So now you have to find out I0. So you see the current direction. So I2 is flowing from top to bottom, whereas I0 is flowing from bottom to top. So these two directions are opposite. Therefore, I0 will be equal to minus I2. So you write I0 as minus I2. So you will get this as the current, that is 6.12 at an angle 144.78 degree. Next problem. Solve for voltages V0 in the circuit shown in figure using mesh analysis. So here if you see this circuit, here you have a capacitive reactance, resistance, voltage source, capacitive reactance, inductive reactance, current source, resistance, current source. So here you find that the current source is common between first mesh and this mesh and this mesh. So if we find a current source is common between two meshes, in this case we have to form a super mesh. So here, since it is common to these two meshes we should combine and form a super mesh. Without considering this current, we have to write the equations. Now let us see how to write the equations. So mesh 3 and mesh 4 form a super mesh due to the current source between the two meshes. For mesh 1, KVL gives. So for this mesh, we have to write the equation. So the equation is minus 10. So current is flowing out from the current voltage source. It's minus 10. Then plus for I1, you have to add all the resistances and reactances in this. That is 8 minus J12 into I1 while writing for mesh 1. Then I2. So you have to identify, that is, which component is common between first mesh and second mesh, that is this one. This is minus J2 ohms. So now if you see the current direction, I1 is flowing from top to bottom and I2 is from bottom to top. Therefore you have to write minus of Ji2, then you have to find out the element which is common between first mesh and third mesh. So that is 8. Again the current directions are opposite. I1 and I3 are opposite. So I3 is flowing from right to left and this is flowing from left to right. So 8 into I3 you have to write with minus sign. Minus I3 equal to 0. So this is the equation. Now you separate I1, I2 and I3 terms. This is one equation. So also you can write that I2 equal to the second mesh, I2 equal to minus 3, because here in the second mesh one branch is having 3 ampere and this current I2 is direction is opposite to this current source direction. Therefore I2 can be written as minus 3 ampere. So that is written here. Now for super mesh, KVL gives. So for this super mesh, I'll tell you how to write this. For I3, for this particular mesh, you add all the elements, that is resistance and reactances in this mesh. That is 8 minus J4 into I3. This is first step. Then again for this mesh, you see what are the common elements. So here 8 is common between this third mesh and first mesh. Therefore, you have to write here 8 into I1. But you have to write the minus sign because these two currents are in the opposite direction. So minus 8 I1 you have to write here. Then coming to this mesh, for current I4 you have to add all the resistances and reactances in this mesh, that is 6 plus J5 into I4. Then you have to find out which element is common between this mesh and another mesh. So only this element is common between this mesh and this mesh, second mesh. Therefore, you have to write current I2 as minus J5 ohms. So minus sign is because these two currents are opposite. And now you can also write another equation for this current source. So you see here, this current is flowing from bottom to upwards. So I4 is also flowing from bottom to upwards, whereas I3 is flowing from top to bottom. So therefore, I can write this current as I4 minus I3 equal to 4 ampere. So this direction is same as that of this direction. So I4 minus I3 equal to 4 ampere. So if this current direction is also same, then you have to write I4 plus I3 equal to 4. Okay, so this is the equation I4 equal to I3 plus 4. Now substitute this I2 equal to minus 3 in this equation 1 and simplify this equation. You will get two equation, that is you will get an equation in terms of I1 I2. Then you substitute I4 equal to I3 plus I4 in equation 3 and simplify this equation. You will get another equation in terms of I1 and I3. So you've got two equations, that is 5 and 6. Now write these two equations in matrix form. Then you are asked to find V naught and the polarity is marked here. So already you know I2, only you have to find out I1. If you find I1, you can find out V naught. So the V naught will be equal to I1 minus I2 into minus J2. That is, see here, the current, this I1 is flowing from top to bottom. So you get this polarity when only when the current direction is like this. Whereas this current I2 is opposite direction, it is flowing from bottom to top. So therefore I1 minus I2 into minus J2 will give you V0. So once you know I1, you can find out the voltage V0. So now write it in the matrix form, then find out delta, determinant of this, find out del 1. So that is, you replace these two elements by this two elements, find out del 1. So obtain I1, that is divide del 1 by delta, so this, which gives us 3.618 at an angle 274.5 degrees ampere. The required voltage V0 is V0 equal to minus J2 into I1 minus I2. So you know I1 and also you know I2. So now substitute the values. I2 is minus 3. So substituting values, you will get V0 as, in rectangular form, it is minus 7.2134 minus J 6.568. This in polar form, it is 9.756 at an angle 222.32 degree voltage. This is about mesh and nodal analysis. I hope you have understood the concepts and the problems. Thank you.